Today, we are going to design the next generation autonomous workflows by building AI agents. These agents are comprised of three main building blocks. One, which is the reasoning engine, which we'd already talked about. These can be completion APIs, themselves powered by these foundational pieces. Then you have your knowledge base or memory, which lends domain-specific knowledge to these agents. This can be medical-related information for medical assistants, travel-related information for travel assistants, and so on. And lastly, we have tools, which can either be used to gather more information, which can be real-time and so on, or they can be used by these agents to take actions in the digital world that they are performing. Now that we have looked at these agents on a conceptual level, let's see how do you go about building one. On an implementation level, these agents consist of four main building blocks. First are the agent themselves, or the configuration of these agents, which basically has the instruction set that lends the personality that that agent uses for domain-specific knowledge. Let's build our first agent. Now we have a lot of different options that we can choose from when selecting one to build our own agent. These range from open source SDKs all the way to managed services provided by cloud providers. So when choosing the right tool for your particular use case, you should remember that some of these allow for more control, but come with more overhead in terms of the lines of code that you need to write even to bootstrap a simple agent. So let's build our flight agent grounded using web search results. We'll start with the necessary setup and imports. We are using two main SDKs, which are the OpenAI ones for basic client connections, and the Agent SDK, which is the new launch from OpenAI, which encapsulates all the necessary helpers for bootstrapping an agent. Then we create an OpenAI client using the OpenAI key, which basically you can supply as part of your environment variables. Let's start creating the basic flight agent with web search step by step. First, we need to import the web search tool, which is a native tool available as part of the Agents SDK. This is the same tool that powers the ChatGPT web search results, which you see in the application. First and foremost, we start by configuring the agent instructions. The instruction is itself divided into multiple sections, as you can see. Firstly, we start with giving the agent a persona by giving it a role. So we specify that it's a flight travel expert whose sole focus is on planning flights. Its task is to generate detailed flight plans based on user preferences and budget. Then we provide guidelines to it as to what needs to be included in the flight plan. This includes duration, exact cost, airline, etc. We also scope the problem down for the flight agent and limit its jurisdiction only to focus on flights. So we explicitly tell it that you should not be considering hotels or any other things apart from the flights. Then we also tell it explicitly that it needs to ground its results using the web search tool. And then we have additional instructions as part of it. We mentioned that it needs to handle missing information if the context is not provided by the user, and also that it should maintain a professional tone because it's an agent typically operating in hospitality sector. Then we come to bootstrapping the flight agent. As you can see, we provide the name of the agent, the instruction set, which we defined above, the handoff description, which is a description of this agent pertaining to the capabilities of these agents. And this will be used, let's say, if another agent chooses to delegate tasks and pass control to our flight agent. Then most importantly, we also specify that it has access to the web search tool, which it can determine to use if necessary. Next, we have some basic model settings, which has parameters like maximum tokens. In other words, these are the maximum tokens that have to be used while generating a response. For our example, we have limited it to 10,000. So our response cannot have more than 10,000 tokens. But if your model supports so, you can keep altering with this number. Then we have temperature, which basically dictates how creative the model gets to be. So higher the value of temperature, the more creative the model is. Then we have some other settings which we can play around with, but we'll not go into detail in this lab. Then one of the parameters is, of course, the tool choice. As you can see, we have opted for the value auto. which means that the model gets to determine at runtime whether a particular tool has to be invoked or not. Some of the other values for this feature is, of course, when you have to enforce the tool call every time. Basically, you can ask the LLM to always have the tool call irrespective of the query, and it becomes fairly deterministic. Right now, we have opted for auto because we want the flight agent to take its own call when deciding whether it needs to search the results from the web or not. So this sets up our basic agent. Next, we move to the user query. So I have a simple query here where I want to fly from Hyderabad to New York, let's say on 15th April 2025. And I specify the budget, which is $1,000 in my case. And hopefully by asking whether it can find me a flight, I'll get the results that I desire for. I'll get the results that I want. Then we have some helper functions to run this particular query using the flight agent that we have constructed above. And as you can see, the response includes, 3 options for me. One from Qatar Airways, and it has all the necessary details that you would consider when, looking for flight options. It also gives me a link as to pointing to the reference or the source from where, it has fetched this particular information.